This is a multimeter and this is a clamp meter which can measure current without cutting the electrical wire. So in this video I am going to show you how to use one of those. So without wasting any more time, let's get into the video. So the first measurement we are going to look at is voltage. At first, let's check an AC voltage. For that, I am using mains AC voltage. Please note that the measuring is done here with full protection, as mishandling mains AC voltage can lead to disastrous injuries. Anyways, the meter shows 242 volts. Now, this meter also has VFC, which stands for Variable Frequency Control. It is used when the AC voltage has a lot of noise. Now it shows 242 volts as this is a stable power supply. For DC voltage, let's try this 6 volt sealed lead acid battery. The meter shows 6.084 volts. Now for measuring frequency. I strongly do not recommend using the separate range for mains voltage or anything above 40 volts. If you definitely want to measure the frequency, then there is a way. First, connect the red probe to the live wire and leave the black probe untouched since it's live. And now we can see 50 Hz comes up. This is a dangerous method though, so I do not recommend doing this at home. Moving on to resistance measurement. Let's try with this 10 ohm resistor first. It shows 10.5 ohms. Now I'm measuring a 1 ohm resistor and it shows 1.3 ohms. By pressing the select key once, we have entered the diode tester mode. For that I'm using a white LED and it shows the forward voltage of the LED. Hitting the function key once again, the clamp meter has entered into capacitance mode. Let's connect a 0.22 microfarad or 220 nanofarad capacitor to it, which comes up as 213 nanofarad. Now let's try this 2.2 millifarad or 2200 microfarad cap, which comes up as 2.6 millifarad. Hitting the select key switch once again makes it go to the continuity mode. Next up is the main current measurement. For DC, let's check out my 12 volt power grid first. I set it to DC and hit the 0 button to remove the excess current caused due to the magnetic field of the earth. And it measures the 113 milliamp of current flowing as 115 milliamps, which is still in the accuracy range of this meter. Now here comes an interesting feature, which is called inrush, which, like the name implies, measures the inrush current. A hack here is that it can also be used in DC too. Now first, we have to turn off the load. Then hook up the clamp meter into one of the conductors and then plug in the load to the socket at the exact time when the meter shows 3 dashes. Now it shows up 4 amps due to my lab bench power supply plugged in. No wonder that my battery pack, which is rated for 2 amps overcurrent protection, kicked in. Now in order to test an AC current that is more than 1 amp, I am going to use a 12 volt DC to AC generator setup. A 775 motor is connected to the output of the generator. Now let's hook up our current clamp and it shows 2 amps AC, which is the maximum my generator can provide. Next comes live detection mode. By connecting the meter to a live source, the buzzer beeps and the backlight lights up. Next off is NCV or non-contact voltage. By moving the meter closer, the dash symbol on the display increases in numbers. The last feature that we are going to look at is temperature, for which my soldering iron set to 200 degrees Celsius is placed on the sensor. Once it reached the temperature, I simply cool the tip of the temperature probe. That's it for this video. I hope you have got something new. Stay tech and I'll see you in my next video.